Good afternoon, everybody. Thank you for joining the last session of our first day of Athena Hackathon 2022. Very excited to be joined by our platinum sponsors and the company powering the event through WebEx. We've got Cisco here and we've got Marcel and Finley to help out. I will leave you in their capable hands. If you have any questions throughout, you can let us know on the chat. As ever, also Discord afterwards. So there's plenty of places to get in touch, and I think we'll be around. So I'll hand over and let us know if you need anything.
All right. Thank you very much, Alex. And if you could quickly confirm that you can see my slides, then
yes, all good.
All right, perfect. So welcome, everyone. My name is Marcel. And today we want to talk about natural language understanding. I'll do a quick introduction about myself before, but we want to talk about mainly two different aspects today. One being, what is natural language understanding? And then I will introduce you to a tool that we have at Cisco that you can use in order to do natural language understanding. I won't say make it simple, but as the title of the slide says, make natural language understanding easier. So to quickly give you an introduction about myself, my name is Marcel. I'm a software solutions engineer for EMEAR Systems Engineering here at Cisco, which is a very fancy name of saying that I work with our big customers on everything relating to programmability. And these days, I mainly focus on collaboration technology, things like, wbex, automating that kind of stuff, and also network automation. But my background is not in networking at all, but more in the software side of things. So I started programming when I was around 10 and been doing it for 15 years now, doing various things and also a lot of machine learning and natural language understanding kind of things. So when we say natural language understanding, what do we mean by that? Well, it's an umbrella term basically to describe the idea that a computer is capable of understanding natural language from a human, right? Like that instead of you having to write something like slash command and then some weird arguments, that you can actually write, hey, order me a salad, and then go ahead. And the computer understands that you do want to order a salad. And even though these kind of things seem very, very natural to us as humans, and because we have had thousands of years of training in our neural networks up here, they are kind of very difficult for a computer. And let's have a look at what makes these production quality conversational assistants one of the hardest AI challenges in today's world, and what makes them so difficult for a computer to understand. Because on the basis of it, right, it's a few words and you just make sense of it. Shouldn't be too hard. One of the first hurdles is this hit or miss accuracy, right? You say things like, for example, with your voice assistant on your phone, you say things like, hey, call an Uber. And then the voice assistant comes back and says, I cannot find a phone number for an Uber in your address book. And what happened here is the voice assistant thought that you wanted to call someone called Uber, but in reality, you wanted to call the app Uber. And as a human, you have the context and you understand, okay, in 80% of the times, if someone says call an Uber, they want to call an Uber and like a taxi and not a person named Uber. But this is like a very, very difficult task for a computer to understand the difference between Uber as a name and Uber not as a contact name. So this hit or miss accuracy is quite frustrating. And maybe you know that from yourself when you're using, for example, Siri on the iPhone or these kinds of services, that they can really be that hit or miss, where sometimes they work great, but then other times they just don't really work. Then, in our day-to-day language, we quite commonly use slang terms, right? That can go misunderstood, right? Show apartments in Zurich, Zurich being a slang word, like a slang term for the city of Zurich here in Switzerland. Everyone who lives in Switzerland will understand what Zurich is and will understand that this means Zurich. But that disambiguation between these commonly used slang terms by humans into their canonical names, right? Like what a computer can actually understand, like nailing it down to, oh, it's all the city, like the city, whatever, postal code 8000 and so on and so on. That is really, really difficult, right, for a computer to do that disambiguation and to understand what if there, for example, also is a city called Zurich. How does the computer know that you're actually referring to the big city in Switzerland and not the small city somewhere in the United States, maybe? So these common slang terms make this very, very difficult from a parsing perspective for the computer. Then you have these dialogues, right? Like, let's say you have an ordering dialogue and you do things like, hey, the computer asks you, the chat assistant asks you, hey, confirm your order for 1 Cobb salad. And you think, hey, I want dressing with that. And if you would be chatting with a human, there would be no problem in saying, hey, can I get dressing on the side? And the human would come back with, yeah, sure, of course you can. Now, the problem is if you do that with an AI or with a natural language understanding, they will most likely be in very set rules on how your dialogue should go. And after that confirm order for 1 Cobb salad, they do not expect the user to say something else. They do expect the user to say yes or no. So they come back with, sorry, I do not understand. So as soon as your user is going slightly off book or slightly off of what you have planned in your dialogue management, this can be really, really hard to capture because basically with a human, you have to, at every point in time in the dialogue, assume that the human can go away and can go somewhere completely different. And then the shallow knowledge, right? Like things like show Oscar-winning movies. Sorry, I do not know how to answer that request, right? In order to be able to really answer questions that you are asking your natural language bot or that you're asking your NLU component to do, they need quite a big knowledge base. They need to be able to do quite a lot of different things, right? They need to have a quite big, deep understanding or a way to look that up. And these shallow knowledge bases quite often fail to answer even some basic questions like show all Oscar-winning movies, right? Trivial to come up with the answer to that. You just go to IMDb and you get a list of all the Oscar-winning movies. But making that connection of, hey, a movie and I want to search for the property that it was Oscar-winning, that is really, really difficult for a NLU platform or for a platform that allows you to do interaction in a chat. And this is why today most chat applications, especially the ones that are being, deployed on the side or not really properly developed, they tend to be really, really bad at answering to a real human being. And they basically fail, the Turing test, right? That famous test that we say, hey, if you can fool a human that the computer is actually a human and not a computer, then you pass the Turing test. And building stuff that can actually pass the Turing test is still quite difficult and is still very, very hard. So natural language understanding, really, really hard subject if you want to master it, if you want to do something that is production quality, right? You can quite fast and quite easily spin up some small example and that, hits in 80% of the time, but making it so that it works in like 99, 95% of the time, that is really, really difficult. And if we look at the landscape of what you can do, there's basically 2 different types of deployments or two different types of ways you can go about building such a platform, right? That you can go about building a bot or building some sort of voice assistant or something that can react to natural language. One is like these data science development platforms, and then there is the web-based NLP services. So what do I mean with the data science development platforms? These are things like, TensorFlow, Core NLP, SyntaxNet, all of these algorithmic packages that are great, like all of the open source, quite often open source packages and modules that you can use in order to build your own data science, in order to build your own machine learning applications. Now, the problem here is that if you go this route, if you build your own based on TensorFlow, right, you train your own neural network, you do all of the things yourself, all of the pre-processing, all of the post-processing, all of that kind of stuff, you are basically, of course, reinventing the wheel and building that kind of production NLP app purely based on data science tools can be quite challenging. I'm not saying that's not impossible, that's impossible, but it is definitely quite challenging, and you are reinventing and building stuff that other people have done. And then on the other part of the extreme, right, like the data science developer platforms are like the extreme of where you build everything yourself, right? You build everything from the base model, the base machine learning model. You build that yourself out and you build that everything yourself. On the other hand side of that are the web-based NLP services, right? Things like Dialogflow, Microsoft Lewis, all of the stuff that has pre-built NLU pipelines where you're basically just doing one API call and you say, hey, this is my language, or this is my string that I got as an input. what do you get me back? What is that? What entity is that? What kind of stuff is that? And the problem with that is that you're constrained, of course, by the service, right? You're sending your potentially customer data to an external service, which depending on data privacy might not be desirable. And also, like, these tools are great to get like a quick prototype up and running, but as soon as you go very, very deep, or as soon as you want to go beyond like the basic examples, they can be quite shallow, right? They cannot have the necessary depth and the necessary ability for you to tune the dials, let's say, in order to really build production-ready applications. So that leaves us at an impasse. Basically, we say, okay, natural language understanding is very, very hard, and there's these two extremes where either I go for a very, very hard problem where I build my own natural language understanding tool set, or I go for the easy route, just outsource it basically to a web-based NLP service, but then I might lack the depth that I need at some point in time in order to build like the really, really deep interactions that I might want to do. So what we have at Cisco is something called Cisco MindMeld. It's a conversational AI platform which provides you functionality for every step of a conversational workflow. So we do everything from the natural language processing part, knowledge base creation. This is like getting knowledge into your knowledge base in order to be able to answer questions, things like opening times or availabilities, these kinds of stuff. Question answering, I pose a question to the system and the question is able to, based on the knowledge base we previously created, answer that question. And dialogue management. So how does the user flow through your dialogue in time, right? Like, remember that example with the Cobb salad, that there is like a different graph, like a different way that the user can go from that part of the dialogue. So this entire platform is a Python-based machine learning framework that uses all of the open source tools that we saw on the left side in the previous slide, right? Like TensorFlow, scikit-learn, NumPy, SciPy. And then it provides you with a layer of abstraction to do these typical tasks that you have in natural language understanding or natural language processing, like domain classification, intent classification, the entity recognition, role classifier, entity resolver, the language parser, and all of these parts of that make a successful NLU pipeline, and we'll be going into details in that in just a second, and allows you to basically skip a bit of the complexity that is built in already, right? Like training your own models and building your own deep learning models. It allows you to go ahead and streamline that work for you. As I said in the beginning, I'm not going to say that this makes it simple. I'm going to say that this makes it easy. So, and you also have the dialogue manager and the question and answering with the knowledge base that I already mentioned. So let's have a look at a sample interaction with a MindMeld-powered or MindMeld envisioned enterprise virtual assistant. And while some of this is specific to MindMeld, or while we're following the same steps that we would do in MindMeld, this is pretty much generally applicable in a natural language understanding pipeline, right? These are the steps that you would take, regardless of the tool that you're basically choosing. So what we want to do here is the virtual assistant use case where you say, hey, schedule a meeting with Janice from accounting from 11 a.m. to noon in Aquarillo, which is our meeting room, which is the name of our meeting room. And then in the backend, we're going to have the system go out, schedule the meeting, invite Janice, book the room for us, and then come back and say, your meeting with Janice has been scheduled for 11 a.m. today, right? That is what we want. We want to give it that input, and we want the system to be able to come back with what we have written on the lower part here. So the first step that we need to do is a step called domain classification. So the idea is that we need to narrow down from the string that we have into what is the broader category of different stuff that is happening. Like, for example, you see it on the right-hand side down there. We have 4 different domains: meetings, which is requesting a meeting to be set up; expenses, which could be something like, hey, check my expense report, or what is the status of my expense report; procurement, which is an ordering; and travel. And you see that we first need to say, okay, this part, this string, or this message that we're getting in is most likely from the domain meetings, right? There's a few giveaways in this string, of course, like the fact that there is the word meeting in there, that there is maybe a time string in there, that there is the name of a meeting room in there. Those are giveaways to the computer and to the statistical model or to the machine learning model in MindMeld to say, I'm 90% sure that this request that you're giving me, that this input there to schedule a meeting with Janice, is from meetings. And you can see that on the lower hand side, MindMeld will not say it is definitely that domain, but rather it will give you a probability. And in this case, yeah, you see with the distribution, it is most likely the target domain meetings. So once we have our target domain, once we know like the broader category that we have, we can go into the intent. So the intent now is within a target domain, you have multiple intents. Like for example, within the meeting domain, you now have the ability to schedule a meeting, right? These are basically like the conversational flows or the conversational tracks that your machine can follow, right? Remember, we're not building a general purpose natural language understanding pipeline that can, or natural language understanding application that can answer to any request, but rather we do scope it to certain parts. And in this case, for example, we could scope it and say, okay, we have the domain meetings, and then within there, we can do things like schedule a meeting, cancel a meeting, check a calendar, help, exit, and greet, right? Like these are the intents, basically, the broad work, I would call them workflows, or the broad flows that you can do. So in this case, again, MindMeld comes back and says, hey, based on, like, I cannot tell you what it's actually doing, but based on the input, based on that schedule a meeting, it's very likely that this intent that we're looking at, so what the flow that we want to kick off is the schedule meeting flow. So again, it will give you a probability distribution and we'll say, okay, 80% sure that this is the target intent. So our output now is we know, okay, within the domain meetings, the input string that we got has the target intent schedule meeting. So that's the most likely outcome. Now we need to do something called entity recognition. So entities are anything that is special or that could be, variable within our string here. So here, for example, we need to understand Janice from accounting is basically two entities. One is Janice, so we need to know that Janice is a person, and then accounting is a department. And then we also have two timestamps in there, 11 a.m. to noon, and we also have Aquarillo. So these are things that would obviously change, right? Every time you do something different, you write a different query, this would change. Maybe this is not Janice from accounting, but rather Jane from HR, right? Like these things can change, and we need to be able to programmatically recognize these entities. And this is what's happening in the entity recognizer step, right? And to give you a bit of background in how this works under the hood, what you're giving MindMeld is a lot of training examples. So you're saying a lot of different strings that say this is how this looks like, or this is how an example could be here. Like, so you would say, hey, schedule a meeting with Janice, or I want a meeting with Janice. So a lot of different examples. And in those examples, you would tag that Janice is a person or accounting is a department. And that way, the machine learning algorithm underneath MindMeld learns to recognize these structures, and then is able to, in the entity recognition step, to say, okay, Janice is a person, accounting is a department, 11 a.m. and noon are times, and Aquarillo is a placeholder for a room, or is a room in that case. With our entities recognized, we now have the information basically extracted out of that entire string, right? So we know that the user wants to do something within the domain of meetings. We know that the user wants to schedule a meeting. So the intent of the user is to schedule a meeting. And we do know who they want to schedule a meeting with, in this case, Janice, the accounting department, and we have like the two timestamps as well as the room. The problem is that we also need to classify the roles here, right? So we need to make sure that our natural language understanding pipeline understands that Janice is the person that we want to have a meeting with, and from accounting can be used to resolve which Janice we're actually meaning, and that, for example, in that little part at the end, from 11 a.m. to noon, that is a time span, right? That one of the ones, 11 a.m. is the start time and noon is the end time. And this is what's happening in our role classification. So you see down there, what's happened is that the two timestamps, so 11 a.m. and noon, got a start time and an end time attached to that, so that's their role now, right? So we now know and understand. Okay, 11 a.m. is the start time, noon is the end time. And again, MindMeld is doing all of that based on your training data in the background for you, right? Or in a natural language understanding pipeline, you would otherwise have to do that yourself if you wanted to recreate something like that. So at this point, we now have really extracted all of the information from this meeting, from this text that we want to write. We know what we want to do. We know what the intent is. We know who. We know the roles. We know like that. Okay, this is a start time. This is an end time. We know that room Aquarillo. What we now need to do is we need to resolve those entities into like unique IDs, right? I cannot just send the WebEx API request and say, hey, schedule a meeting with Janice. The service will come back and say, who's Janice? Like we need some sort of like, for example, a person ID, or we need some sort of like email address, something that uniquely identifies that person. The same for the room identifier, right? In most room booking systems, you would have something like, for example, a room calendar or these kinds of things. So what we need to do is entity resolution using a entity resolver. So what happens there is we're converting things like the person information, right? Like Janice, based on the information that we have with the department, maybe we use some sort of internal sources, for example, a directory or corporate resources to say, okay, this is Janice Smith, employee ID 82417. And then the department, we can resolve that to corporate accounting with that department ID. What we're also doing, as you can see, is with the timestamps, for example, we are resolving them into proper timestamps, right? With a date in front of that, right? So far, we only had timestamps. We want date times, right? With a date, we're also adding some specific daylight time there, some time zone information that are assumed based on the user, for example, what kind of time zone they are in when they're chatting. And as you can see, we're also resolving the room into its canonical name, like SFO 12, probably the building number 12 in SFO, third floor, and then the name. So we have gone from just the name that is more human readable into that full like calendar, for example, or the room identifier that we can have. So with our entities resolved, with our roles classified, we can then do the language parsing. So we can now go ahead and go out and actually go into our dialog manager. So we can say, this is our target dialog state, right? The booking, book meeting. So this is where we could now. This is basically now the part that if you were to implement something like this with MindMeld yourself or in a normal pipeline yourself, this is the part where you would start writing the code, right? You would basically have a function in Python that gets all of these inputs, like all of the fact that all of the outputs from the entity resolver, all of the outputs from the recognizer, all of the outputs from the role classification, and then it says, okay, what do you want to do now? And what you want to do there most likely is you want to do you want to either use your knowledge base that you have pre-populated. You see down there the question answer.get from an employee index, right? That employee ID and the department ID to get the person that should be invited. And also you see down there like question answer.get that from the room. So this is using a knowledge base that you have previously filled. You now get the email address, for example, or of the location and of the person that you're inviting, and then you can use in part of that step, you can do an API call, for example, to the WebEx API, in order to create an appointment with that invitee, with that location, with that start time and that end time. So basically, this is where whatever you want to do with the information that you have received from the person, this is where the magic happens. This is where you're basically doing that via, for example, external API calls. And then we also want to give back some sort of output, and this is also part of the dialog manager. So for example, the dialog manager can then go out and you can have, for example, 5 different ways of replying, and it will randomly choose one of them so that it doesn't feel that static, so it doesn't feel like you always get the same response back from there. And also, of course, you can fill in all of the information that we have previously resolved, like your meeting with, in this case, Janice, right, as a placeholder, and then it's scheduled for 11 a.m. today. So that's also part of the dialog manager. That's sort of the final step, right? Combining all of the information again into one and giving you that back. So that is a broad overview, I would say, of the typical steps that go on when you're interacting with these kinds of services, when you're interacting with these kinds of automated response systems. This is the same if you're, for example, interacting with some of these chatbots that pop up on web pages that say, hey, can I help you with something? Everything you type in there goes through a pipeline like this. And depending on how deep you're building that, better the answer is going to be, or the worse the answer is going to be. So just to quickly summarize the benefits for you in a nutshell, this is tech that is actually cutting edge, right? Like the language models and all the stuff that is within MindMeld is used by us ourselves, right? We have MindMeld. We use that, for example, for wbex assistant. So the way that you can say, okay, wbex in front of a device, for example, and then voice control it. So we use MindMeld for that. And that's where the drive comes from. It is a one-stop solution. So you can see we covered the entire natural language understanding pipeline in one of the frameworks. And it is on-premise deployable. So your data, your rules, there is no cloud. You're not sending the requests anywhere that you want to do. Now, you might be wondering, how can you try this out? What can you do in order to get started with this, and how much is it going to cost me? Well, the answer is it's not going to cost you anything because MindMeld is open source. So you can head over to github.com/cisco/mindmeld, which is the current branch of our development, and you can try out this framework for free and use the framework like any other open source solution. If you do want to use it, if you do want to get started with it, I would highly recommend you use the docs on mindmeld.com/docs. There we have I think it's 10 steps or 12 steps playbook that basically walks you through the entire process with examples actually in MindMeld of building a production natural language understanding application based on MindMeld. So they go every step and they once again explain everything that we have covered already, like the dialog states and all of that kind of stuff. The intents, the domains, all of this information are covered once more in that playbook. So if you do want to use MindMeld, I would highly recommend you use that, or you have a look there. With that being said, thank you very much for joining today, tonight, wherever you are in the world. Maybe it's lunchtime. And if you have any questions, feel free to raise them in the chat window. I think Finlay and Alex are on the panel already. And if you have any specific questions, I know I didn't go very, very deep into like the back end stuff and then into like the pure math behind natural language understanding, feel free to shoot me an email or reach me out on Twitter or on GitHub, wherever you can find my information.
Thank you very much, Marcel. Very good session indeed. I think, as you say, if there are any questions, obviously let us know. Both Finley and myself are on hand to help answer. Well, I say help answer, ask Marcel, and I'm sure he can answer. But yeah, let us know. And I mean, as I mentioned at the start, I'll kind of reiterate again, I know people will be watching this retrospectively too. So if you are, feel free to catch us on Discord. As Marcel said, there's various details there. So, or if you just can't think of a question now and you think of one in 5 minutes time, then we're always reachable there. So yeah, there's plenty of ways to go. But before that, and I guess while we're waiting for questions to flood through as well, just a big thank you to you, Marcel and Finley, giving up your time. I think hopefully everyone enjoyed it and appreciates it. And I think there's definitely some useful stuff for those watching that are participating in Athena at the weekend. There's definitely a few useful bits that they can take into the weekend hack. So it'll be interesting to see how that's used, to see how that's explained, and to see if people reference it in their projects. But yeah, a big thank you for your time.
My pleasure.
Cool. It doesn't look to be like there are too many questions in the chat at the minute, so I think we'll wrap up. And if there is anything, or in fact, there was one about NLP and NLU being different, I believe. Just reflecting back on that, I don't know if someone was surprised or asking a question, but I don't know whether you can shed any light on that, Marcel. That was toward the start.
Yeah, so natural language processing is the pure processing part, and I would say natural language understanding is like the umbrella term around everything, right? Like the actual making sense of that is I would say the NLU, right? I would say natural language understanding covers everything. Like it's basically making a computer able to understand human language. You could argue that transcription, right? Like the taking a voice stream and turning it into text so that it can then be fed into something like MindMeld is part of NLU, which I don't know if I would classify it as natural language processing, but I wouldn't like maybe there is an academic definition that how they are different, but I would go with natural language understanding as like the umbrella term in natural language processing, a subspace of that.
There we go. Well navigated. I think that makes sense. So we'll see. But no, good question. Thank you. Thanks for that. Like I say, keep them coming on Discord or whatever if you have any retrospectively. But I think a big thank you to you, Marcel. And yeah, thank you very much, everyone, for listening.
Thank you.